So as we go through here, just the same way that I went around by 30 degrees and just added 30 each time, that very first radian measure is pi over 6. Alright, so I'm going to do the same thing, but with my radians. So if this is pi over 6, this is 2 pi over 6, and 3 pi over 6, and 4 pi over 6, and 5 pi over 6, and 6 pi over 6. I'm going to come back and reduce. 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6. Alright, so, and then I guess here's 12 pi over 6. Now, I just went around adding 1 each time, but some of these will reduce. So instead of 2 pi over 6, I'm going to erase that one. I'm going to change it to pi over 3 because it will reduce. Instead of 3 pi over 6, I'm going to erase that. 3 over 6 reduces to 1 over 2, so pi over 2. 4 pi over 6, what does it reduce to? 2 pi over 3. 6 pi over 6 is just pi. 8 pi over 6 is 4 pi over 3. 9 pi over 6 reduces to 3 pi over 2. And 10 pi over 6 is 5 pi over 3. So that reduces everything there. Now I have neglected the 45 degree angles. I'm going to go back and do the same thing with my 45 degree angles. So if I start here, this is 45 degrees. So if I just keep adding 45 degrees, if I go that same distance, there's 90. If I add 45 again, that gives me 135. And then if I add 45 again, that's 180. If I add 45 again, I get 225. If I add 45 again, I get 270. 45 again is going to give me 315. And then 45 one more time gets me back to 360. So you're doing the same thing, but with your increments of 45 degrees. 45 degrees is pi over 4. And so if this is pi over 4, I'm going to write it, but I don't have to. This is 2 pi over 4. This right here would be 3 pi over 4. This would be 4 pi over 4. 5 pi over 4. 6 pi over 4. 7 pi over 4. And then 8 pi over 4. But the ones I wrote there in blue, they reduce. We've already got those. Pi over 2 is pi. 3 pi over 2. This one I didn't reduce. This one's just 2 pi whenever it reduces. So that fills in all of your degrees and all of your radians for unit circle. There's other things that you can memorize. Here 6, 4, 3, 2, and then here is 6, 4, 3, 2 on the other side. As far as your denominators go, those are always the same. If you have trouble memorizing your unit circle, you can watch a million YouTube videos on different ways people memorize this. So they can be helpful. Now, what I'm concerned with are those coordinates that we just found. So we found that this was square root of 3 over 2, 1/2. This was square root of 2 over 2. This was square root of 2 over 2. And this was 1/2 square root of 3 over 2. And so if you know how to figure your degrees and radians, and you know the first quadrant of the unit circle, you can figure all the rest out really easily. Because this point right here is just this point reflected over the y-axis. So if I put this over here in the third quadrant and second quadrant, my points will be the same. I'll have square root of 3 over 2 and 1/2, but my x will be negative. Same thing happens with our square root of 2 over 2's. They're going to go here. Just reflecting it over that y-axis. It's just going to make the x coordinate negative. And then my 1/2 square root of 3 over 2. I'm going to have a negative 1/2 there. So you can just use that symmetry of the graph to flip these over here. Right? You have the same y-coordinate because they're at the same height, but your x's are opposite each other because they've been reflected. I could do the same thing by reflecting this over the x-axis. So if I reflect this over the x-axis, this point right here is going to be the same, square root of 3 over 2, 1/2, except for now, which coordinate is negative? The 1/2, that y-coordinate. And so right here I'll have square root of 2 over 2 and negative square root of 2 over 2. And then here I'll have 1/2 and negative square root of 3 over 2. And then finally, you can either use this or this to reflect over the y-axis here or the x-axis here. You're going to get both of those are negative. So you got negative root 3 over 2, negative 1/2, negative root 2 over 2, negative root 2 over 2, and negative 1/2, negative root 3 over 2. And then the last ones we have, these are just like your plotting coordinates. So if right here is my origin, and the radius is 1, what's my x-coordinate here? 1, and my y-coordinate is 0. At this point, x-coordinate is 0, y-coordinate is 1. Here, my x-coordinate is negative 1, y-coordinate is 0. And then down here at the bottom, x-coordinate is 0, y-coordinate is negative 1. So those are just like plotting points right there on the axis. So this is your unit circle. We have it all filled in now. And you do have to have this memorized. We will next week, probably Tuesday next week, we will have a quiz on the unit circle. And that quiz will be that sheet that you have right there, except for I'm probably going to print it on white paper, and it will be blank. So you will need to be able to fill in that unit circle without looking at anything by probably Tuesday next week. Okay. Now, let's look at why we even need to know the unit circle, because this seems like a lot of useless knowledge here that math teachers across the universe created to torture young minds. But especially if you think about going back to before calculators, it could be extremely helpful. However, we don't even like to think about that, but it would be very helpful. But it also, the next section we're looking at, we're going to be graphing sine and cosine functions. So this gives us the key points of sine and cosine functions that we need to know. Because I'm going to go back to this very first picture. I'm going to erase some of the stuff that I had there just so that we can look at this. And I want to look at just like what we started with. We had an X here and a Y here, and we knew that was 1. All right, so you can just watch what we're doing here. So if I were going to do some trig, let's say I was going to try to find that X coordinate. All right, if I was going to do some trig and I wanted to find that X coordinate, then which trig function would I use? I know this radius right here. I know the hypotenuse. So I need to use one of the trig functions that involves hypotenuse. I do cosine, right? Because this right here is my adjacent and hypotenuse. So I could say cosine of 30 degrees equals x over 1. Well, that just means x equals cosine of 30 degrees. My x right here we found was the square root of 3 over 2. So when I look at that unit circle, the x coordinate, that is my cosine of 30 degrees. Now, normally we just type that, everything we've done so far, we just type cosine 30 into the calculator. And when we type cosine 30 into the calculator, it would give us a decimal. Let's do it. So we would type in cosine of 30, and it would give us the decimal 0.866025. But notice if I do square root of 3 over 2, I get the same decimal, right? So the unit circle allows us to find values of sine or cosine even whenever we are not allowed to use our calculator in cases like this. So I know that cosine of 30 degrees is square root of 3 over 2. In a similar manner, if I'm going to find y, I would say sine of 30 degrees equals y over 1. Thank you, Jaden. And so sine of 30 degrees is y over 1, which just means y is sine of 30 degrees. So this 1/2 that we found here, that is sine of 30 degrees. All right, and if you type in sine of 30 degrees like we've been doing on the calculator, you get 0.5, which is 1/2. So the unit circle gives you sine and cosine. At the very top of your unit circle there, you have, oh wait, went too far. You have something that says x equals blank and y equals blank. So there for your x, you're going to put cosine of, I'm going to use a theta. It's like a 0 with a horizontal line through it. They use that for angles a lot. And then sine of theta. And Jaden, let me give you notes here. Okay, so a few things that we're going to look at. A radian is a distance that we use to measure like a length around the circle. Like here our radius is 1. So if I could do a radius of 1, if I went around the circle, it would be 1 radian. And then I'd have 2 radians and 3 radians and 4 radians. Usually I do activity with this, but I didn't have time and a lot of people were gone. So how many radians would it take to go all the way around the circle? Okay. How many degrees does it take to go all the way around the circle? 360. Radians is going to be 2 pi. Not 2 radians, but 2 pi radians, which 2 pi is going to be like 6.28 something, 6.283185. Now, let's think of, I want you to think for a second about where this comes from. How do I find circumference of a circle? Pi times diameter. But let's say I don't have diameter. Let's say I just have the radius. Right? So, well, or it doesn't matter. What's the diameter of this unit circle? It is 2. The radius is 1, so the diameter is 2. Right? So if I want the circumference of this circle, it is 2 pi. So 2 pi is the distance it takes to go all the way around the unit circle, which is equivalent to 360 degrees there. So when we're converting radians to degrees, the key that you could use 2 pi equals 360 degrees. But both of those are divisible by 2, so it would be better for me to say 180 equals pi. So half of the circle, 180 equals pi radians. So one thing that we're going to have to be able to do is to convert degrees to radians and radians to degrees. Now some of these we could just look on our unit circle and find, but other ones like 55, that's not going to work. So I'm going to show you a way that will work every time. You can sort of memorize rules, and that's fine also, but I like to do these using proportions. So I know always 180 is the same as pi, right? So I could set up 180 over pi equals 135 degrees over, I don't know how many radians 135 degrees is, so I'll put an X there. Now you could set up this proportion differently if you wanted to. You could say like 180 over 135 equals pi over X, or you could say 180 over 130. You could say pi over 180 equals X over 135. You can set up proportions a lot of different ways. But if we set up using that 180 and pi, we could cross multiply, so we get 180 X equals 135 pi. And then X is what I'm trying to find, so I would divide off by 180. And typically with radians, we want to leave pi in our answer, so I could type in 135 pi divided by 180. I could do that, but it is going to give me a decimal, so that the answer is 2.35619 radians, but usually you don't see it written like that. Instead, I'm going to take 135 divided by 180 and reduce it, and I get 3/4. So this will be 3 pi over 4. Look on your unit circle, see if that's right. Is that 3 pi over 4? Okay. So another thing that you can do if you get stuck on memorizing those radians is you can convert using this, although you probably won't have your calculator, so you'll have to reduce 135 over 180 by hand for that, which wouldn't be too bad, but also not the most fun, especially if you're trying to do the whole unit circle that way. It would be pretty tedious. All right, for 270, I can set up the same thing. 180 over pi equals 270 over X. And so I would cross multiply. 180x equals 270 pi. And I divide by 180. So in this case, X would equal 270 over 180. It's going to be 3/2, but if you're not sure, 270 divided by 180. Math, enter. And we get 3/2, so we get 3 pi over 2. Is that right on your unit circle? It is. Now where this really becomes necessary is when you've got a problem like number 3. Because even if you have the unit circle memorized perfectly and you could just look at it, then 55 is not on your unit circle. So for this, you would definitely need to set up a proportion, or you'll notice our rule is kind of like your multiplying by pi divided by 180, that if you'd rather use that rule. So 180 over pi would equal 55 over X. And so we would cross multiply, just like we did on the last problem. We'd get 180x equals 55 pi. And we would divide by 180. And when we do 55 divided by 180, we would get, enter, 11 pi over 36. So 11 pi over 36. Okay, so this is how we convert from radians to degrees. One reason I like setting up a proportion is because you do the same thing to convert from, sorry, I said it backwards. This is how we convert from degrees to radians. For the second part of this, we're going to convert from radians to degrees. So you set it up just exactly the same way, except, like right here, I'm going to say 180 over pi equals degrees go on top. So I'm going to have an x up here, and then I've got 2 pi over 3. Okay, so you're going to solve the same way here. You're going to cross multiply. So this time you get pi times x equals, and you've got to do 180 times 2 pi over 3. I would leave off the pi. I would do 180 times 2/3, which is going to give us what, 120? 120. So you get pi times x equals 120 pi. And then divide both sides by pi, which will cancel that pi on both sides, so we get 120 degrees. And if you look at 120 degrees on that unit circle, it should be 2 pi over 3. For number 5, you've got 180 over pi equals x over 5 pi over 6. Cross multiply here, you'll get pi times x equals, let's see, 180 times 5, 6. It's going to give us 150, so 150 pi. Then the pi's just cancel on both sides, so we get 150. Be careful on one like number 6. Because 4 and 5, our pi's canceled out, so we just marked them out, right? Number 6, you don't have a pi in your radians, so the pi's not going to just cancel here. So we'll have 180 over pi equals x over 1.35. And so we will cross multiply pi times x equals, and right here I'm going to do 180 times 1.35, and I get 243. Now, that does not have a pi with it because 1.35 did not have a pi. So I have to divide by pi here, and it's not going to cancel out. So I have to do 243 divided by pi. So I'll get 77.349 degrees. We'll round to 3 places there, so 77.349 degrees. Typically, if you have a decimal in the problem, you end up with a decimal in your answer for those problems. Okay, questions? Okay, the last thing we've got to do is learn like how to use our unit circle to find values here. So, oh no, it's not. I did show you guys this because I got a little ahead of myself with some stuff, but trig functions. You have not seen secant, cosecant, or cotangent very much at all. But I did tell you earlier, you don't necessarily have to write this down unless you want to. We know sine of theta is the reciprocal of cosecant theta. And cosine of theta is 1 over secant theta. And tangent of theta is 1 over cotangent of theta. And then the opposite is also true, so cosecant of theta is 1 over sine theta. and secant of theta is 1 over cosine theta. And cotangent of theta is 1 over tangent of theta. So those are what we call the reciprocal identities. So I'm going to teach you another identity here that also is going to apply, because the unit circle only gives me sine and cosine. So if I am asked for tangent of something, it's going to be difficult to find that from the unit circle because I only have sine and cosine. But tangent is sine, let me just write the whole thing. Tangent of theta equals sine of theta over cosine of theta. You don't have to write this down, but just as a real quick proof of that, sine is opposite over hypotenuse, right? Cosine is adjacent over hypotenuse. How do we divide fractions? Flip the second and multiply. So opposite over hypotenuse times hypotenuse over adjacent. What's going to happen with the hypotenuse in the top and bottom here? They cancel, giving you opposite over adjacent, which is tangent, right? So that's sort of like a quick proof of making you definitely believe I didn't just make that up and tell you to memorize it, even though it's wrong. So tangent equals sine over cosine. Secant of theta we already had is 1 over cosine of theta. Cosecant of theta is 1 over sine of theta. So you can see here everything's in terms of sine and cosine. There's no tangents involved. Cotangent, what do you guys think cotangent is going to be? If we use this reciprocal identity right here, it's 1 over sine theta over cosine theta. And dividing fractions is easy as pie. Flip the second and multiply. So you're right, it is cosine theta over sine theta, which kind of makes sense. These are called reciprocal identities. They flip that sign. So if you are asked for tangent, secant, cosecant, or cotangent from the unit circle, you're going to have some extra work to do because you have to use these formulas here. Okay. All right, questions so far? So it is equal to both. You can use either, but 1 over tangent would be 1 over sine over cosine. And then so dividing fractions is easy as pie, flip the second and multiply. So that would give you cosine over sine. So you could use either one, but when it comes to using the unit circle, it is much easier to use this because you've got cosine and sine. That if you did this, you'd have to find tangent first and then do 1 over whatever you got for tangent. So it just makes it a little bit quicker to find the answer if you use this instead of these over here. But all of the ones we have here are true. There. If for some reason you knew tangent right off, you could just do 1 over whatever tangent was. Okay. So let's look at some unit circle stuff. And I did everything in radians here because I imagine that's probably what we need practice with because degrees are a lot easier. Your homework will have a little bit of degree practice there. I may not do every one of these problems. We'll do several. So let me just show you how to use the unit circle. So if you have sine or cosine and a value that's on the unit circle, it makes it much easier to do than the other. So for number 1, we have sine of pi over 2. So we are going to go to our unit circle. I'm actually going to, see, let me lock all this in place so I don't, yeah, okay. So pi over 2 is right here, 90 degrees, right? And sine, is that my x-coordinate or my y-coordinate? Y. So sine of pi over 2 is 1. So my answer for this would just be 1. So if I look at number 2, it asks for cosine of 5 pi over 6. So let me erase this. This time, we're looking on our unit circle at 5 pi over 6. It's right here. Cosine, is that my x or my y coordinate? It is x. So that's right here. So cosine of 5 pi over 6 is negative square root of 3 over 2. So that's your answer. Let me use that. Over here. It's not quite as much. Okay? Alright. Now, this next one's a little trickier because negative pi over 3 is not on our unit circle. But pi over 3 is on our unit circle at 60 degrees. Right? So the unit circle goes in a counterclockwise direction. If I have negative values, it tells me to go the opposite direction. So rather than being 60 degrees in the counterclockwise direction, if I go 60 degrees in the clockwise direction, it gets me here to 300 degrees or 5 pi over 3. All right. So for this one, this is negative pi over 3. The other thing you can do for that, negative pi over 3, I can always add or subtract 2 pi because that's a whole rotation. So it's going to get me right back around to where I was. So if I add 2 pi to this, negative pi over 3, that's like over 1. So you'd have to get common denominators. Multiply by 3. Multiply by 3. So we'd have plus 6 pi over 3, and that would give me 5 pi over 3, which is where I'm at right here. All right, and what were we looking for, sine or cosine? Sine, and sine, is that my x or my y coordinate? Y coordinate, so my y coordinate right here is negative square root of 3 over 2. So, negative square root of 3 over 2. 3 pi is not on the unit circle. But I can always add or subtract 2 pi and it'll get me right back to where I should be. So if I take 3 pi and I subtract 2 pi, that means this is the same as sine of just pi. Alright, so if you look on that unit circle, pi is right here. Sine is my y coordinate, so 0 is sine of 3 pi. Okay, questions so far? All right, number 5. This one starts to get a little tricky because I've got 11 pi over 2, negative 11 pi over 2 at that. So that's definitely not on our unit circle. So there's a couple ways that you can do it. And I'll show you what I consider the long way, and I'll show you what I usually do, which is, I think, shorter, but some people don't like it, so it's up to you, whichever one you want to use. So negative 11 pi over 2. All right. It is it's too low, right? It's not on our unit circle because it's too low. So I could add 2 pi to it. And if I add 2 pi, just like I did before, I've got to get common denominators. So I'm really doing negative 11 pi over 2 plus 4 pi. over 2. And when I do that, I get negative 7 pi over 2. Still not on my unit circle. So I could add 4 pi over 2 again. That gives me negative 3 pi over 2. I might could figure it out now if I wanted, but I could just add 4 pi over 2 again, and I get pi over 2. Right? And so negative 11 pi over 2 is equivalent to pi over 2. And so then I could just look on my unit circle right here at pi over 2. What was it, sine or cosine? Cosine, which is my x value, so I get 0. Most of you will probably do that because I know how much all of you love fractions and dealing with fractions, so that's probably what you will choose. But let's say that there's a person out there that might not like fractions as much and does not want to have to deal with those fractions. This is what I usually do. Pi over 2 is a quarter of the circle, right? So I start right here at 0, and I'll say 1, and I'm going to go clockwise because it's negative. 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2, 7 pi over 2, 8 pi over 2, 9 pi over 2, 10 pi over 2, 11 pi over 2. So I'm just going around a quarter of the circle at a time and counting up to 11. And when you get there, you're at pi over 2, which is the same thing we found the other way. So if that makes sense to you, you can do it a lot quicker that way than having to add or subtract the whole time. If it were positive 11 pi over 2, I would have went in the counterclockwise direction as I was counting. Right there. All right, let's skip on down to number 7. Okay, I want you to have some time to work on your homework. So if I've got tangent of pi over 4, tangent's not on the unit circle, so I have to think of this as cosine of pi over 4 over, sine of pi over 4 over cosine of pi over 4. And if we look on our unit circle, what is sine of pi over 4? 45 is your degree for that. Square root of 2 over 2. And what is cosine of pi over 4? It's also square root of 2 over 2. I could do like dividing fractions easy as pi, flip the second, multiply, but anything over itself, even if it's something complicated over itself, it's still 1, right? So we're going to get 1 for that answer. Let's skip down here. Let's do cosecant of 2 pi over 3. So we'll skip down here to number 10. Cosecant of 2 pi over 3. Cosecant's not on the unit circle. So cosecant is going to be 1 over, is it sine or cosine? It's sine of 2 pi over 3. All right. So if we look at our unit circle, see 2 pi over 3 is 2 pi over 3 is right here. And so we want 1 over sine, right? Is that right? Yes, 1 over sine. So sine is square root of 3 over 2. So, okay. So what we know, this is going to be 1 over the square root of 3 over 2. Now we got to simplify this some because we can't leave our answer like that. So dividing fractions is easy as pi. We're going to flip the second and multiply. So we get 2 over the square root of 3. And I can't leave my answer like this either because I have a square root in the bottom. How would I get rid of that square root in the bottom? Good. So square root of 3 and square root of 3. So that is going to give us 2 times the square root of 3 over 3. I realize that looks more complicated than 2 over the square root of 3, but the powers that be of math teachers everywhere decided we need to do this. Good news is when you get to calculus, they don't really care if you leave square roots in the bottom anymore. You can leave that as your answer. But for some reason in pre-cal, every textbook and all the tests and everything always rationalize the denominator. Let's see. Let me see if there's another one we need to look at. Let's do. Let's see. One here somewhere. Okay, let's do number 8. Let's get back to it. Okay, secant is not on the unit circle, so we have to do 1 over cosine of pi over 2. And when we look at our unit circle, pi over 2 is right here, and we want cosine, right, which is 0. So that means that we're going to get 1 over 0. What is 1 over 0? You can't do it. You cannot divide by 0. If you type it in the calculator, 1 divided by 0, it's going to give you an error. We call that undefined. So sometimes you're going to get one that's undefined for these. Okay, but remember, what is 0 over 1? What does that equal? That's 0. So if you got 0 over 1, that is 0. It's not undefined there. 0 over 1 is 0, and 0 can be an answer for these. But 1 over 0 is going to be undefined. Okay, what questions do you guys have? All right, so I'm going to give you guys a worksheet.